Hi guys. Okay, welcome back. This is page 130, and I wanted to touch base with you on seeing what you did for the equation here. First of all, make sure you read and reread. So what I did was, as you can tell, I underlined some key things, and they're just giving us a situation. So they're just not flat out telling us what the slope or the y-intercept is. So we've got to kind of decipher all the information, organize it in an organized fashion, and then write our equation. I still haven't written the equation, as you notice, because I wanted to talk to you about some of the things with this table. We have weekly allowance, and it depends on the number of chores this has done. I guess his name's Harry. Love their spellings. So I started making a table. Notice the table, though. So I really had to think about, well, what was changing each time? And that's the number of chores. So your X value is your chores. Notice it is not the very first thing listed. So don't just go into robot mode of, okay, that's the first number, you put it here, second number, you put it here. Well, the amount of chores and then the amount of money he receives from those chores. Also notice, you could do this to where we put our 12 chores first, which is fine. If you do everything mathematically correct, you should get the same amount per chore, so your slope. So I did 8 chores for $14, 12 chores, he earned $16. So we need to find the slope here, meaning what's the rate of change? We got to figure out how much he's making per chore. All right, so we have the difference between 8 and 12 and the difference between 14 and 16. So it's the change of y. So what's this going up by? It's going up by 2. What's this going up by? It's going up by 4. Be careful. It's your change of y over your, oh God, I can't get this up. Change of y over change of x. So it's 2 over 4, which is 1/2. Now we're talking about money. So they're going to say, your parents might say, hey, I'll pay you per chore. I'll pay you $50 for per chore. So $50 is what? 50 cents. So I haven't changed it yet, but this is going to be 1/2 x plus b. Well, we don't know our y-intercept. It's not flat out telling us. So we got to figure this out. Well, figure out this table. If it's going down by 4, this goes down by 4. That's going to be 4. Goes down by 4 again. That's going to be 0. So we want to get x to be 0. If this is going down by 2, well, that's going to, so that's going to be 12. 2 more, it's going to be 10. So our b is our 1/2 x plus 10. Now, let's rewrite this to make sense. We can rewrite it in money, so it's going to be like 50 cents. It's okay to put the 0 here since you're talking about 50 cents. 50 cents x plus 10. So 50 cents per chore, and he got $10 for maybe a basic fee just to do some, I don't know, one-time $10 fee. They don't give us enough information what that 10 is telling us. But he got the $10 once, and then he's getting 50 cents per chore for that week. Okay, so there's your equation. All right, so down here we have, you should have paused and done this, hopefully. But Lila's making beaded necklaces. So for each necklace, she uses 27 spacers plus 5 beads per inch. So our input value, our x, is going to be the length of the necklace in inches. Our output variable, our y, and in science, we talked about this already. In science, you call it independent and dependent. Independent variable, because that's going to change. Your y is dependent on your x value. All right, so your y is the total number of beads in the necklace. Now your equation. All right, for each necklace, she uses 27 spacers, no matter how long the necklace is. That is a one time, so that's definitely your y, or your y-intercept. Okay, so what we're trying to find is your slope here. What is happening, like your x is the length of necklace in inches, you're using 5 beads per inch. There's your equation. That's going to tell you how many total beads you need for the necklace, depending on how many inches you want to make it. Okay, this one on 2, she's planning a trip to the beach. Here's the information you got to come from. That was just a situation. Here you've got to decipher from the graph. Now, what's nice about it? There's your y-intercept. So she estimates her travel speed to her graph to expected progress on the trip. Write an equation slope-intercept that represents the situation. Choose 2 points to find the slope. I would find exactly where they cross, that one and that one. Now you can do it by the 2 points or by counting. This difference here is 300. That is 5. So 300 over 5, because that's your change of y, rise over run. Now notice it's going downhill. So her distance is 300, but as she drives, as she not increases her speed, but as time passes, her distance is less. So this is going to be a negative. 300 divided by 5 is 60. Because 5 goes into 36 times, and then that's 0. Read the y-intercept from the graph. That's, y-intercept, that's your 300. Here's your equation. That negative 60x plus 300, meaning she's starting at 300 miles away from her destination. She's traveling for every hour she travels 60 miles. So she's getting closer and closer to her destination as the time passes. Okay, she has less miles to go. That's why you need to do negative 60. Okay, this is so funny. This was a scenario I think I was talking to my algebra students about, the crickets chirping. Okay, well here's the information. At 59 degrees, crickets chirp at a rate of 76 times per minute, and at 65 they chirp 100 times per minute. So write an equation slope-intercept form that represents the situation. Our input variable is the temperature. So that's what's changing. The output is your chirps per minute. Chirps per minute. Okay, so we need to look at our slope. So I'd make a table to make sense of this. So our x and our y. So the input is our variable. So at 59 degrees, they chirp 76 minutes. At 65, they chirp 100. Okay. Now, 100 minus 76 and 65 minus 59. 76 to 100 is 24. And 59 to 65 is 6. Change of y. So change of y over change of x. I hope you can see this. Yeah, you can. 24 over 6, that means it's going to be 4. So they're chirping 4 times per minute per degree. So this is going to be, our slope is going to, from our work over here, it's going to be 4. Use a slope in one ordered pair, to find b. Okay, they're doing it because if we kept doing this down to 6 and 24, they're trying to get us to find the b from an equation. So this is a 2-step equation, which you guys have done last year. So we'll do this. Y equals 4x plus b. Well, we're trying to find the b. So let's pick one of our ordered pairs from here. Try to see if there's one that's going to be simpler, and it's not. All right, so let's do our ordered pair. 65. Let's just do 59 and 76. Our y value was 76. 4 times 59 plus b. Now, 4 times 59. All right, if you want, pause, and you can get a calculator. You can also do 4 times 60 and then subtract 59. Actually, subtract 4. Okay, 4 times 59, 76 equals, oops, I think my screen went down, 236 plus b. So you want, now this is a 2-step equation. Multiply these. You want to still solve for the b. So how are you going to get b by itself here? Well, you want to subtract 236. To subtract these, you're saying 236 minus 76. And that should be, now it's a negative 160 because 76 minus 236 is a negative 160. So you're feel free to use a calculator right now if you want. We'll go more into this definitely when we do equations. All right. Okay, I think this, we've just done it here. So is your 160 is your b. So your slope is y equals 4x minus 160. Whew, you might just think of two-step equations here. But we'll talk about more. What we did was take this point, 59 and 76. You could have done 65 and 100 too. 65 here and 100 here, and it should still work out. Explain the b and the m. This is going to tell you about the graph of the line of the equation. Well, the slope is going up, and you're starting at a negative 160. Okay. Explain what b and m tells you about the graph of the line of the equation. All right, we'll come back to that. I'm brain dead right now. Okay, pause.